First, I'd like to thank everyone for the invitation to attend this conference. I'm really excited to learn about the work that's been going on in this project, and I'm hoping to bring back some tools and ideas and techniques to my work with the HathiTrust to help us with some of the problems that I'll explain now. I have to preface this by saying that this is not going to be a terribly technical talk, so I'll leave that to Clemens and everyone to follow me. I'm going to be mainly talking about the HathiTrust, and just to give you some context about what it is, it's a collaborative digital library project that was started a few years ago amongst academic libraries to aggregate content and build services on top of it. Mostly was formed around Google Library Partner content, but there is other content as well. This is a list of all the current HathiTrust members. I've bolded the one non-US member, which is Complutense. There are about 13 other members on the cusp of joining, including some Canadian libraries, so we will have a few more non-US members. But as you can see, it's very US-centric at this point. I hope that changes in the future. Also, I'd like to point out that of the 5 original Google libraries, we have 4 on board in Harvard, Stanford, Michigan, and the New York Public Library. University of California was number 6 in joining Google. And again, UC and the Committee on Institutional Cooperation were the 2 founding members of the HathiTrust. And I'm going to mostly be talking about the corpus and some of the issues that we have because we're working at a pretty big scale. As you can see, it's nearly 10 million volumes that we hold right now. It's almost all book-like content. There's very little non-book-like content. 3.4 billion pages. It's a lot of stuff. Little over a quarter of it is in the public domain. And I believe this public domain figure is for the US, not international. I don't know the exact percentage for international public domain. This data is taken right off of the front page of the HathiTrust. There's some interesting visualizations on the HathiTrust website. You're able to kind of break things down by ranges of dates, subjects, and languages. The subjects are based on the Library of Congress classification codes. This is a breakdown of dates, and as you can see, nearly 2/3 of the corpus is pretty modern, 1960 and newer. Here are some of the languages, almost 50% being in English, but there are a great number of other languages included. Each of these slices, as you mouse over them, if you click, it will take you, it'll do a query against the corpus and bring up materials just in that segment, if you will. So US libraries, well, I'm speaking for the University of California, but I think I can generalize, and I think that US libraries have been very opportunistic in their digitization efforts, particularly with Google. As you know, in the States, we like everything bigger. So rather than focusing on digitizing specific collections, we wanted to digitize as much as possible. And as a result, we've got some issues with size. I'm going to talk about the index that we've built off of the full text of these 10 million volumes. So again, this is all from OCR content and OCR done by Google. There's no keyed text that I'm aware of. The HathiTrust uses Solr as its search engine and indexing technology. It was selected for its ability to scale searches across large bodies of content, using distributed search and sharding. In general, I think most libraries favor open source tools rather than proprietary ones. Obviously, a main motivation there is going to be cost, but particularly in the HathiTrust, we're eager in working with developer communities to improve tools. And the HathiTrust has really helped Solr push their boundaries. When we first started using it, Solr had a maximum unique number of terms of 2.1 billion. We went past that pretty quickly, and the open source community was able to really quickly, in working with us, turn around a fix in, I think, 2 or 3 weeks to increase the number from 2.1 billion. It's 290 some billion. So I don't think we'll be bumping up against that ceiling very soon, at least I hope not. One of the things I forgot to mention earlier in talking about the corpus is we're estimating that it contains between 800 billion and 1 trillion words. So again, size very, very, very much a challenge for us. In releasing our full-text search, we were motivated really just to get it out there and get it working. We're now faced with the task of improving it because, as you'll see in some of the slides as I progress, there are a lot of issues with what we have there. So the size of the index is 6 terabytes total, which is about 2/3 of the size of all the text documents that have gone into creating it. Now, obviously, that's a little too big to put on any one machine and do queries against. So again, Solr has this idea of sharding, where the index is split up into separate shards that can be searched in a distributed manner. Our index is split into 12 different shards that are on 6 servers. Each shard contains about 3 billion unique terms. That doesn't mean that the whole index is 3 billion times 12, but we don't know the exact number of unique terms at the index right now. It'd be a lot computationally intensive to really figure that out. Reindexing is done nightly and incrementally. We've only reindexed the entire corpus twice. We estimate right now it'd take 10 to 14 days to complete a full reindex, although with some tweaks to the software, we're hoping to get it to 4 to 5 days, but still it's kind of a cumbersome process, and we don't have 1 million computers at our disposal, so we'll stick with the nightly for now. The size of the index obviously directly affects the performance. Performance is always going to be a struggle working at this scale. It's been our intention to return all queries within 30 seconds, which has been a challenge. I think the average query is returned in under 10 seconds, so we're doing okay. But it's taken constant effort and work on memory management, constant monitoring of query response times. And one of the sad things about the size of the index is some of the loss of functionality that we have because of its size. We're not able to do wildcarding because of query latency. It just it takes far too long for a query to return. And also there's a lot of difficulties in, ranking the relevance of your results and making them easy to use by your users, also, subsetting within and faceting. There's a lot of languages represented in the Hathi Trust. There are over 400 languages in the collection. 50% of those are English, and English being one of the languages that is dealt with effectively by the OCR engines. But what about those other ones? The modern OCR engines handle about 60 languages total, and only 20 of those does it do well. So there's 340 some other languages that are getting no love. If a language isn't identified when OCRing, you get gibberish or empty OCR altogether in some cases. We did just go through the corpus to look for books that had empty OCR. We only found a very small portion, 0.069%, which is only 6,700 books. So that's good, but that means that there's a lot of gibberish OCR in there, and we knew that. Here is a lovely example of a book in Mongolian and Russian, although this is a Mongolian page. And as you can see, it's very clean, it's very pretty, and this is what the OCR looks like. It's neither clean nor pretty. So dealing with all of this, it's a lot of complex issues, obviously. Um, Filtering or pre-processing of dirty OCR before indexing needs to work across all languages. That's very difficult. The content in the corpus is from a very broad variety of disciplines. It's a wide range of time periods. And so improving OCR training or OCR corrections is going to require lots of different kinds of dictionaries, technical, academic. As we saw in the last presentation, when you've got a very good dictionary, you can get good improvements, but what about those 340 languages for which there are no dictionaries currently? Other complexities, multi-language texts, and compiling a good ground truth collection is kind of critical in training your engines. Google has been collecting as much as possible, working with Project Gutenberg and a number of other projects. They have the advantage of working with a number of commercial partners to accumulate a very big collection. They're not necessarily sharing it, but hey, we can work with them on that. One of the things I learned from Clemens just recently is that as part of Impact, you're putting together a ground truth center and an open one, which I think is great and will really help training the engines and moving forward. So I'm going to talk about some of the failures. You guys are all well acquainted with what failures look like and corrections. So it's obviously more effective to improve the OCR engine than it is to try and fix things after the fact. We don't really have that luxury, being that we're mostly working with Google. And the HantiTrust has pretty limited resources, both in terms of computers and humans. It's a collaborative project where all the partners contribute voluntarily. So already our libraries are strapped for money and resources, and to further spare resources to work on HantiTrust projects is difficult. Why does the OCR fail? You guys are all well acquainted with the reasons. Language might be misidentified. Page sections might be misidentified, images and figures being interpreted as text. Because of the breadth of the collection, there's huge variations in book design and fonts, page decorations. You've got physical and condition problems, marginalia, all these kinds of things contribute to bad OCR. There was a UNLV study done somewhat recently that found that bad OCR increases the number of words per document by about a third, 34%. That's not good. So you've got all this dirty stuff. How do you go about fixing it? HantiTrust has been pretty conservative in its approach to fixing the OCR. We are more interested in, most interested in not removing anything that might have any use for an end user. One of the things that's been suggested and investigated is not indexing words that have a mix of alpha and numeric characters. Seems like a no-brainer, but it would prevent people from searching for unique terms. In the States, there is a nonprofit status described as 501c4. You take that out of the index and people don't get to it. 101 Dalmatians. The example that the trombone is there for is 76 trombones, which it's not just a song from a musical, but it's a term that was used by the United States Secretary of Defense during Vietnam in his requests for position papers. And so it's a very useful thing to have in the index and be able to search on if you're interested in those kind of documents. Other kinds of corrections that have been investigated are removing tokens that only appear once throughout the entire corpus. Unfortunately, we found that 50% of the tokens in the index only occur once in the collection. That's not great. But if one of these unique terms occurs in a query, your most relevant documents are going to be at the top of the results because they've got a very high inverse document frequency. And so you don't want to remove anything accidentally that would give you the best result. Martin Reinert from Tilburg did some estimates on the Reuters corpus, and this wasn't OCR, it's just typos, but found that by removing single occurrence words, over 32% of legitimate unique words are also removed, and also 35% of the incorrect unique words remain. So you gain something, but you certainly lose a lot as well. This is a scale model of San Francisco made out of toothpicks. And just put this up here to try and give an idea of the complexity and intricacy of the things we're trying to do. Google is working very hard to improve their OCR extraction, as you all know. They've got a very smart team. I know some of you have met some of them. They recently switched to Tesseract from Abbey 9. And Tesseract is an open source OCR engine that they developed in-house and are very committed to continuing to develop. I think you know that Google owns reCAPTCHA and is using reCAPTCHA technology to correct OCR. They've developed a system they call voting where different copies of public domain works are compared to one another to try and identify textual inconsistencies and fix them. I don't know all the details. I have some concerns about this because of different editions and whether they're identifying exact copies correctly, but it's one of their approaches. They have a tool that they've developed to work with layout definition. They call it Goo Doctor. Working on phrase correction by language and image model. As Clemens also mentioned, I lead a working group of Google library partners and Google engineers which focuses on quality issues. It's not specifically OCR quality issues. We kind of cover a broad gamut. And we're just starting to dig into OCR quality in the Google corpus. In large part, that's the reason I wanted to come here, is because of this work and what we might bring back to improve things. One of the things that, you know, it's a good starting place, but is only the tip of the iceberg, would be for Google to be able to deliver for each book or each page some kind of OCR quality score so that we have a sense of what we're dealing with in each book, each page. We'd also like some more information from them on how effective some of their correction methods are, how much coverage there is across the corpus, how much is being corrected. I'm sorry, I know I speak very quickly, but I want to thank you again for being here. I also want to thank Tom Burton West from Michigan, who has led the majority of the full-text search work for the HathiTrust and provided a lot of the information that I've talked about here. As difficult as the problems are that we face in the HathiTrust, I'm optimistic that they won't be proven intractable, but they're going to require a lot of time and effort to work through. And again, I'm hoping that from being here, I can learn from all of you and what you've learned to try to bring some tools back to help us improve things. You know, we can start chipping away at the problems little by little, and, you know, it'll keep us busy and employed for quite a while to come with 10 million volumes. One of the other things I hope to gain from this conference is perhaps some new collaborations across the pond. We haven't worked a lot with European partners, and you guys need more ground truth data. We've got lots of data. You guys have tools. We need tools. I think there's a lot of opportunity for us to work together. Last thing is, if anyone is interested in learning more about the full-text search in HathiTrust, there are a lot of documents and resources on the HathiTrust website and a blog about some of the work that's been done. So I encourage you to visit, and thank you again for inviting me. I appreciate it.
Thank you, Paul. You did actually catch up for some lost time, so that was brilliant. We do have time for a question Are you all desperate for lunch, are you?
That's what I was trying to do.
There's a question? Please.
Hi, you mentioned the solar indexing of languages. Or is that the only kind of multilingual indexing you're using, the ones that are supported by solar?
Right now, yes.